Hey guys, we're going to look at trig ratios again today. This time we're going to be looking to solve for missing side lengths or missing angles. We'll still use our trig ratios, so sine, cosine, and tangent. So here's a triangle. This time what we're solving for is a side length. We are given one side length and an angle. So we're going to look at the angle that we're given. And it's always going to be the acute angle. We'll never look at the 90-degree angle. So we look at our acute angle, 28 degrees, and the side length that's given, and we decide what two side lengths are we given in relation to this angle. So we have the opposite side and the adjacent side. And then we think of our trig functions and decide which trig function, sine, cosine, or tangent, uses the opposite and adjacent. And we think, well, that's tangent. So we know we're going to have to use tangent in order to solve. So we set up an equation. We have tangent of our angle, so tangent of 28 equals x over 9. And anytime you have a trig function of an angle, that can go over 1. So really we have a proportion. Tangent of 28 over 1 equals x over 9. We can cross multiply. 9 times tangent of 28. Divide by 1 doesn't do anything, so 9 times tangent of 28 gives us our x value. So this x value, or our side length, is 4.79 roughly. Okay, here we're going to solve, in this picture, we're going to solve for x and y. So again, we have an angle and we have one given side. We have to decide, obviously this is our hypotenuse. I didn't draw in the right angle, but that is the right angle. So we have our hypotenuse, x would be opposite. So we have x equaling our opposite over hypotenuse, which if you go back to your trig table is sine. So again, set up a proportion. Sine of our angle, sine of 52 degrees equals opposite over our hypotenuse, so x over 12. Cross multiply, we get x to be roughly 9.46 units long. Y, however, is our adjacent side. So here's our angle, y is adjacent, 12 is still our hypotenuse. So to solve for y, we're going to use adjacent over hypotenuse, which is your cosine. So cosine of 52 equals y over 12. Cross multiply, we get y is roughly 7.39. So here I'd like you guys to find x, and you can round to the nearest tenth. So we've learned how to solve for a side length. The next examples we're going to solve for a missing angle. So here we're given a triangle, right? Triangle with two different sides. We have 6, and then we have our hypotenuse is 11, and we're supposed to find angle A. We're still going to have to decide which trig function to use. So side length 6 is the adjacent side, 11 is the hypotenuse. So adjacent and hypotenuse are cosine. So adjacent over hypotenuse would be 6 over 11. In order to find this angle, we're going to have to use what we call the inverse. And it looks like cosine to the negative 1 power. That's what we call the inverse, and it's used to find those missing angles that we're looking for. This is a button on your calculator. Normally it's above the sine, cosine, and tangent buttons, and you'll have to push like the second button on your calculator. So we do the inverse cosine of our fraction. So if you typed in inverse cosine of 6 over 11, we would find that our angle is roughly 56.94 degrees. So this angle is roughly 56.94 degrees. What if I asked you to find angle B? Well, you could set up another fraction similar to what we just did for A, but also we know that there's 180 degrees in a triangle. So I went and found angle B, just knowing 180 minus my 90-degree angle minus angle A gives me angle B to be roughly 33.06. And lastly, given this triangle, I'd like you guys to find the measure of angle A.